This is part 4, the test of autocorrelation, that is Durbin-Watson test or DW test. Here we consider only the first order autocorrelation, that is ut is equal to rho ut minus 1 plus epsilon t. Rho is the autocorrelation coefficient. We consider small size sample here. There is two hypotheses. H naught is null hypothesis, that is rho is equal to 0. There is no autocorrelation. And other is alternative hypothesis, there is autocorrelation where rho is not equal to 0. Durbin-Watson statistics is defined as D is equal to sum of T is equal to 2 to N ut hat minus ut minus 1 hat whole square divided by sum of T minus T is equal to 1 to N ut hat square. In the next line, sum of T is equal to 2 to N. The square term, it's use the formula A minus B whole square, that is ut hat square plus sum of T minus 2 to N ut minus 1 hat square plus square term is missing here. So here I need to write square at this line, means ut minus 1 the square and minus 2 sum of T minus 2 to N ut hat ut minus 1 hat divided by sum of T is equal to 1 to N. Similar line from the previous equation, from the previous value, that is sum of T is equal to 1 to N ut hat square. So here 2 sum of T is equal to 2 to N ut hat square minus 2 sum of T equal to 2 to N ut hat ut minus 1 hat, it's divided by sum of T is equal to 1 to N ut hat square. Here sum of T, it's from this equation, from this line, that ut hat square, it's approximately similar to sum of T is equal to 2 to N ut minus 1 hat square. So expected value sum of T equal to 2 to N ut hat square, similar to or approximation of sum of T equal to 1 to N ut hat square. So it's equal to, from here, that 2, because already considered that ut T equal to 2 to N ut hat square equal to sum of T equal to 1 to N ut hat square. So this 2 term cancel out and only 2 it's left here, minus this minus putting here, and 2, this 2 put here, and the other term sum of T equal to 2 to N ut hat ut minus 1 hat divided by sum of T equal to 1 to N ut hat square. It's approximation of 2 minus 2 rho hat, approximation of 2 taking common 2, and that is 2 first bracket 1 minus rho hat. If rho hat is equal to 0, D is equal to 2. If rho hat is equal to 1, D is equal to 0. If rho hat is equal to minus 1, then D is equal to 4. If D in between 0 and 2, then rho it's positive. If D in between 2 and 4, then rho it's negative. So from this diagram we can say that this zone it's positive autocorrelation. This zone is for negative autocorrelation. This is inconclusive zone. This is also inconclusive zone, and this zone from up to this such zero autocorrelation, that means there is no autocorrelation, it's considered. And in the horizontal axis, consider d is a function and this is the origin O, and in the vertical axis and d is a function, horizontal axis, consider d Durbin Watson value, that is dl du theta minus du theta minus dl. So if d star is in between dl and du, or d star in between du and 4 minus dl, this is test is inconclusive. That means d star is in between dl and du. In this zone, no result, and d star in between du and 4 minus dl, du 4 minus dl, test is inconclusive, or it is better to say 4 minus du and 4 minus dl, then in this zone result is inconclusive, and d star is less than dl, we reject h naught of no autocorrelation. H naught, that means rho is equal to 0, accept no autocorrelation, reject h naught, that means null hypothesis is rejected, so no autocorrelation, reject h naught, that means no autocorrelation, or accept in favor of positive autocorrelation. D star it's less than dl, that means in this zone there is positive autocorrelation. And if d star is greater than 4 minus dl, we reject h naught and accept in favor of negative autocorrelation. Reject h naught, that means h naught indicate that there is no autocorrelation, but we consider that there is autocorrelation with negative autocorrelation. If d star in between du and 4 minus du, we do not reject h naught, that means there is no autocorrelation exist.